Alright, we're recording now. Alright, well, we missed the first 8 minutes.
And will you recap what I've done in the first 8 minutes, since I was here for the last 2 of those?
That's pretty much it. So we were looking at ways to specify a file that we would then pass to a scanner. I think that was all we did, other than be reminiscing on multiplexers and demultiplexers from 250. All right, so other questions? All right, so let's take a look at the ODP. So we are looking at ODP 304. So this, you can look on Canvas and see that this opened and is open until Wednesday morning at 8 o'clock. And then 305 will open Wednesday morning at 8:05 and will be due on Friday. So these are, 2-day versions of ODPs because we got Monday, Tuesday class. So ODP 304, reading integers from standard in. This is something you've already done. This should be pretty much a slam dunk, other than trying to package everything into a class. So you're creating a class named add class. And it's got a constructor and 2 public methods. The constructor should do 2 things. It should have a variable in the class which stores a running sum that we're going to keep adding things to. And this should be declared, outside of all of your methods, just as, an integer inside the class itself. And you can call it running sum or whatever you want. And in your constructor, initialize that to 0 and also open a scanner on system.in for reading from standard in. So have a scanner object that's also part of the class outside of every method. So declare it, as a variable in the class, but then construct the scanner inside the constructor for add class. And then you have 2 methods. Read, which reads 1 integer from the user, right? So 1 line, so you can just use next line and parse it as an integer. Reads 1 line and adds it to the running sum, and then it just returns. And then there's a sum method which returns what the current running sum is. So test code, you might do something like this. You might say add class AC equals new add class. Right, so construct an add class object. And then if you say AC.read, that should pause and wait for me to type something in and hit enter. And it'll take the thing I entered and it will add it to an internal running sum. And if I say AC.read again, it will ask me for a second integer. And then if I say system.out.println and I do AC.sum, that should print out the sum of the 2 numbers that I typed in.
Can I make a correction for what you wrote down?
Yeah.
So we say add class AC equals, I think is that AC?
Mm-hmm.
AC equals new add class. You have to put something inside those parameters.
Nope.
It's like system.in, right?
Nope. No arguments to the constructor.
Really? I put down system.in, and I basically what it was like getting input from standard in.
The constructor sets an internal running sum to 0 and opens a scanner for reading from standard in. There's nothing about the constructor that does anything with an argument. So the constructor should not take an argument.
I'm not talking about the constructor. I'm talking about when you create a scanner. What you call a scanner, you put in like inside the parameters. System stuff.
Yes, inside the constructor for add class, you're going to construct a scanner. And the way you're going to do that is, scanner equals new scanner system.in. That's correct.
Yeah, that's what I was talking about.
Okay, yeah.
But when you're that's the main program. I'll think about inside of add class.
Yeah, so inside add class, you'll be doing this.
Yeah, sorry about that confusion there.
Nope, no problem. All right, so if I call add class read twice and then I call add class sum, that should show me the sum of the two numbers that I typed in. If I say ac.read again, it should stop and ask me for a third number. And then if I do something with ac.sum, that should return the sum of the three numbers that I typed in. So each time I call add class, add class.read, it reads another number, and then add class.sum at any point will give me the sum of all the numbers that have been read so far. So it's kind of a weird, sort of stateful kind of class. And let's be precise about this. So this business of, in fact, let me just this business of reading one integer from standard in, use the next int method in the scanner class. Don't read an entire line and parse it as an int. Just use scanner.nextInt. So scanner has these has nextInt and nextInt methods. And assume there's no errors going on anywhere. So has nextInt should definitely return true, and then nextInt should just return the next integer that was input. So you don't have to do any parsing, you don't have to do any error checking. Anytime read is called, just use the scanner's nextInt to get an integer, add that to your running sum. Anytime sum is called, just return the value of the running sum. So it's like a 4 or 5 line ODP. And test it with, maybe some sample code like this on your own main program. And then when it's working, go ahead and assess it with this magic assess line. All right, questions about that?
To point out that before you even edit that, I looked up to figure out the scanner object. Then I found nextInt, and I thought, I can use that.
Ah, cool, awesome.
So, but if you were to just use next and you put out an integer, would it take an integer as a string rather than a number?
It would take it as a string, and then you'd have to use integer.parseInt to convert it to an int. And that would end up being exactly the same behavior.
Which makes me think that if you were to parse it, what would happen if you were to put a number in with any non-numbers like a letter or and if it parses and we use parse int, does it only like copy the integer into int and then exclude any other characters? How does it work?
So parseInt which is in the integer class, right, takes a string, and if your string was something like, 23J, parseInt will throw an exception. It'll be a number format exception. So it's not like scanf that would just go up to the 3 and stop and say, oh, you got a 23, right? ParseInt will try to parse the entire string as an integer. And so if there's extra stuff in there, it'll throw an exception.
That's when you use the try catch block?
That's when you would use a try-catch block, exactly.
Okay, cool.
All right. Let's see. All right, let's talk about PA2. So PA2, I started grading the ones that were submitted over the weekend. If you made changes and resubmitted by Monday morning at 8, I'll regrade the latest one you submitted. But I started taking an advanced peek to see what people were doing, and it looked like people were nailing this. And so PA2 was looking really good. I don't know how many people are using slip days. I don't think I want to go over PA2 code today. I think I'll leave that till Wednesday. Actually, let me take a quick look.
If we make edits to our code and turn in by late morning today, like you said, that would constitute slip day being used, right?
So anything that was submitted by 8 a.m. Monday, that's what gets graded. So if you're going to use slip days, don't turn anything in until you're ready to have it graded. But if you turn it in Saturday and you turn in another version Sunday and you turn in another version Monday morning at 7:55, it's that 7:55 version I would grade. If you're going to use a slip day, it'll be the version that's available 8 o'clock Tuesday morning that I would grade for one slip day, and so on.
I was just asking based on what you just said earlier about if you said never mind.
Sure.
I was just confused because you said if we turned it in on Sunday or something, then and you looked at it and made grades and.
Okay, so basically here's the exact algorithm, right? Monday morning, this is for a Monday morning due date. Monday morning 8 a.m. I'll download everything that's available and I'll grade that version of it, right? Over the weekend I had some time, so I started looking at submissions that people had already made, but I know some people submitted things early and planned to go back and try to fix them up if they had time. So anything that got submitted, in here doesn't necessarily, end up being the one that I grade. The one I'll grade is the ones that are available Monday morning at 8 o'clock, right? Anything that's not available then, I'll do another download Tuesday at 8 a.m. So if the first time you upload something is somewhere in here, right, whatever the last one is that's uploaded before Tuesday at 8, that's the one I would end up grading.
And that's also the one that you would take a slip day from.
Yeah, and so this would be one slip day. And then same thing Wednesday, Thursday, Friday, and so on.
Okay, I get it now.
Cool. Yeah, it's I haven't found a less confusing way to describe all of that. Yeah, so I've only got 9 submissions. So I'm gonna hold off on going through sample code for PA2, but I want to talk about some of the general issues I'm seeing so far.
Really short.
It once you figure out how to nail it, it's pretty short. But that's the whole process of getting into an object-oriented way of thinking about things, and so getting there can take a lot.
it only took me like 130 lines of code, and that includes the comments.
Cool.
So
Yeah, mine was something like that.
Awesome.
but Nick, you said it didn't like in like 80 something lines of code. Was that with or without the comments?
That was with comments, but not as much commenting as I want you to do. I went back and looked at it. I didn't have my block of comments in the beginning of each method and so on. So.
Yeah, mine ended up being around 90 something with comments.
Yeah, so I mean, it should be doable in about 40 or 50 lines of actual code, probably less. But then depending on your commenting and you know, do you put a brace on a separate line by itself, that kind of stuff, it can vary wildly. But the actual amount of Java code is fairly slim, because you know we're doing so much of just kind of putting wrappers around other things. That this other stuff does the heavy lifting for us.
I get a very curious question.
Yeah.
When I comment my code, does it actually increase the size of the file? It's kind of a dumb question to ask that, but I was kind of curious. Because if somebody wanted a file that's very small, do I have to cut out a lot of the commenting I have to do, or do I look up to the comments and not worry about the size file?
So
ask for it small.
The commenting will increase the size of the .java file. That's your source file, right? But the class file should not be affected by it unless you're compiling with a -G switch, and then I think it might include the comments. I'm not sure. But generally, you know, the comments get chucked by the compiler, and so they don't affect the final size. I don't know about things like, you know, very long variable names. Because it's interpreting, I don't know how much it keeps those and how much it changes them into internal representations. But you know, usually we can be as verbose as we want in our source code and not worry about performance issues and so on. Now, a purely interpreted language will get slower the more commenting you have, the more white space you have, because you know a simple interpreter is reading through your file as it's processing it. So a bash script, for example, may run marginally slower if you have lots of comments, but it's usually negligible. But yeah, size for the class file I don't think should be affected. So a couple of general comments I'll make up front. The first is keep your try-catch blocks as small as possible. I saw some code where, you know, it was like try curly bracket, and then the entire main program, right? The entire add references method, whatever we called it, was inside one try block, where you're trying to open the scanner to read from the file, and then you're pulling in each line, and you're calling cleanup, and you're calling add reference, and you're closing it, and you're returning, and all of that was in one try block. Do not do that, right? Use your try block when you really can't avoid throwing an exception. You don't know if this file exists. You could use the file exists method, right? But the file should exist, right? We expect that, so throw it in a try-catch block. But just put the try block around that one statement, which is where you're constructing the scanner. And then get back to top-level indenting. Well, yeah, come by office hours. Let's look at your code, because it should not throw errors. Compile errors or runtime errors?
Compile errors about like variables not being defined or something like that.
So remember this one funny business. So if you say scanner s equals new scanner, and you put this in a try statement, and you have a catch statement, and then you try to do s.next, right? That will throw an error because s does not exist out here, right? S was defined inside this try block. So before the try block, declare your object, and then construct it inside your try block.
Will I lose points for that? 'Cause that's...
No, not this time.
Okay, yeah. It's kind of a...
That threw me off too, especially when like I was like, oh, variable is not defined. Oh, I have to make it global. But is it possible I can just have a I call the variable private scanner s, so that way the main program doesn't access it. Or I was thinking like that's good. If that's a good way of, if that's good practices for coding.
Yeah, to call it what? What did you say?
Oh, I was talking about if I had made a variable. Well, if I said private scanner s, like make it a private variable.
Mm-hmm.
That's what we're doing.
So if it's defined inside, if this is all inside your method, then you don't need to worry about the scoping, right? It's local to whatever method you're inside here, and so it's not even accessible outside of that method. You could make it a variable in the class itself and declare it private, but that's kind of using a global where you don't really need a global. Right? The only place you need to use this is inside your main process file method. And once you exit that method, you don't need the scanner anymore. You're going to construct it inside here. You're going to close it at the end. So you could just make it a local inside here. But yeah, if you set it up in the entire class, that also takes care of this issue.
Okay. Thanks.
Yeah. All right, the other thing I want to mention, I'll talk more about this on Wednesday, but a few people changed what, for example, the add reference did. For example, they had add reference take the string and convert it to uppercase. And that's not what add reference is supposed to do. Add reference is supposed to take a word and a position and record the occurrence of that word to that position. And there's nothing in the description of add reference about converting it to uppercase or incrementing or decrementing the position or things like that. And you can do those things and still get a main program that looks like it's doing the right thing, but you want to be really careful in general when you're implementing a method and you're told what that method should do. Make sure you do exactly what that method says and nothing else. This is another version of putting a print statement in your stack pop method. Well, in the end, when you run this particular main program, it looks like it's doing the same thing, because when you pop something off the stack, it prints. But if you change what the pop method is doing, and somebody else wants to use that method, now your code is misbehaving. Right? So as I give you these specifications for methods that you're required to implement, try to use those as practice to get really good at following the spec exactly. And that's going to be critical at a university and in some of your more advanced programming courses, that you don't change the spec or the behavior of these functions or methods, and you get really good at following them. So that's another no deduction this time kind of thing. But I'll mention that in my feedback comments, and that's what it's referring to.
Samuel has a question.
Okay.
I think, yeah.
Thanks, man. So I got a question regarding trying catch blocks, from earlier.
Regarding your what?
So the, trying catch blocks,
Mm-hmm.
like with first regarding them,
Yeah.
while I was developing my PA2 code, I tried, doing an if statement inside the try part of the block,
Okay.
and it gave me like two errors about like the same block when I tried to compile, saying that that try has to be paired with catch and catch has to be paired with try.
Okay.
Do you know why putting it in the try part of the try catch block would cause that? Such a thing?
So it should not cause a problem. Ifs are perfectly legal to put inside tries. My guess is going to be maybe you had an extra closing curly bracket in your if statement, and it thought you were ending the try block prematurely or something. Or maybe the catch ended up getting subsumed as part of the if statement. But I'm guessing it was some kind of syntax issue. But what you're describing is legal and should be something you can do, having conditionals inside the try or the catch block. So that would be one to, if you can show me some code that was misbehaving, we could figure that out.
Okay. Just thought might as well ask.
Yeah, definitely.
I was gonna type this out to you, but I'm not supposed to say it. In the add reference, what I did in the add reference method was I checked to see if the string was empty. I was gonna do that in like the other method for parsing a word,
Mm-hmm.
but the thing is that I cannot return nothing if it's returning an empty. If I have to return a string of some sort, right? So what I did was, because the add reference is returning a void, if the string is empty, I should return nothing. It's actually, and that's kind of what I did.
So add reference doesn't say anything about empty strings. And it actually should add an empty string if you pass an empty string to it. And so before you call add reference, check to see if the string has a length of 0. And if it does, just don't call add reference, don't increment your location pointer.
Yeah, the way I made it was kind of like, to kind of give a little layout, in the add reference method, I was going to check if the string is empty.
Mm-hmm.
The string is empty because if I were to put it in the other method, I would have to return something, but I can't return nothing from a method expecting the string. But anyways, but I made actually a variable called like a Boolean variable to check whether the string is empty or not.
Yeah.
And that's for our main program too. And the main program, or actually not the main program, is it the main program? I don't know.
Process file, I think.
I think it's a process file.
Yeah.
In the process file, I made a quick little if statement that checks if it's not empty, then increment the counter. If it is empty, don't increment the counter.
Right.
Because when I saw your test output
Mm-hmm.
assignment, I kept on this issue where I had an empty string added, but then I realized it took me a while to figure that out. But
Mm-hmm.
that's a little comment for anybody. We're still working on PhD where what I did was I just kind of made extra variable for checking, or extra Boolean variable that checks whether the string is empty or not, and that's for the process file to see whether or not to increment your file,
Mm-hmm.
or increment your counter. But there's other ways of doing it, but that's my way of doing it.
Yeah, and I think what you did was inside add reference, you checked to see if the string was empty, and if it was, you set that flag and returned.
Yep.
And then in process file, you said if the word was not empty, increment the position count.
Mm-hmm.
And the only issue with that is that you're doing something different from what add reference is supposed to do, right? Add reference should just add a word to the index. And so that check to see if the word is empty, you could just move that outside of add reference and say if the word's not empty, go ahead and add reference and increment the position count. And in other words, do that check right after cleanup word before you add reference.
So you think you're allowed to add empty strings to the, because I thought you're not supposed to add a empty, or it's not okay to add a empty string to the list of words.
That's part of process file.
Well, I guess I did a little cleanup there. That's not needed at all, but
Mm-hmm.
at least to me the output looked a lot nicer.
Yeah, no, I mean, you do not want to add empty words to the index, but that's part of the specification of the process file method, not the add reference method.
By
So,
empty string, you just mean like a string just made up of two double quotes, right?
Yeah.
Not just
yeah, something with a length of 0, not a null or something weird like that, but just a string that has. So if your input was like 1, 2, 3, when you call cleanup word, the result's just going to be, no characters. So that's what we mean by an empty string.
I have a question about the particulars of toString that I encountered.
Okay.
This caught me by surprise, but when I was testing with your main program and it was checking to see what the index would print out as, if it didn't have anything, it should be printing out as null.
Right.
And I kept getting this weird exception that I ended up fixing by doing it a different way. But if I tried to call index.toString when it was undefined and it was null, it would throw an error, and that makes sense, I guess. But if I did index, like if I printed like index plus a blank string, so that Java would convert index to a string again, it would print null with no issues. So why is it that it gives an error? It doesn't allow me to toString with the method directly. I can do index.toString, but I'm allowed to concatenate with a blank string, and Java will then handle it fine.
So I think the string concatenator is just being a little too smart instead of being standardized. So if index is equal to null, and I return index, I've returned null. And if I try to print that with a print line, it'll print out null. If I try to do index plus quote quote, it's not calling the toString method on this because there is no way I can call index.toString if it's null. So it's being smart, right? Which is making it inconsistent in its behavior. It's seeing that you're trying to concatenate a null to a string, and it's I don't know what it's doing. If it's returning a 4-character string, or if it's changing this into null, I'm not sure. If you certainly if you say index.toString, now it's saying, hey, you're trying to call a method from this object. What's the object? Oh, it's null. Throw up and cause an exception. And so I was going to say your best bet is, if index equals null, return null. Otherwise, return, and then you could do index plus quote quote or index.toString or whatever. But rather than checking to see if index is null, see if your processing succeeded, right? So you have this Boolean flag you're setting after you successfully create an index because you processed a file. That's the thing to really be checking. And so your logic here is, if did process return index plus quote quote, otherwise return null, or something like that. If you didn't process, return null, otherwise return index, or index.toString if you like.
Yeah, I originally wrote a check for that using an if statement because it was throwing that exception, and that's kind of the behavior I was expecting. That's kind of very explicit behavior that you would expect.
Cool.
And I found that just returning the null object plus a blank string, the string concatenator just handled that fine for me, so I didn't even need the if statement.
Yeah.
It's probably not generally good thing to write. My other question, I guess, is I didn't ever try returning just the index object on its own because I figured I'd be returning a null object, but I'm not returning a string, I'm returning a null hash map. So if I tried to print that null object, it might have given me, no, wait. I couldn't return it because I was returning a hash map object, but the method was looking for returning a string, so I didn't think that would work.
Yeah, nulls are funny. So let's just dig into this for a second. I haven't tried this.
Ominous.
Yeah, definitely. Let's see. Let's start with that. Alright, so that says x equals null. So the question is, what if we put it into a string? Still says s equals null. So what if we do that? Right, so it's actually 4 characters. So it's actually, when you convert a null object into a string, it actually changes it into a 4-character string, null, which is interesting.
That sounds very illegal in my opinion.
Yeah, yeah.
Usually no is supposed to mean like nothing, like doesn't exist, or you know, or usually for C we use no as like a kind of way to indent that it's like the end of string or end of something, you know.
Mm-hmm.
Kind of like I'm thinking binary search trees for some reason.
Yeah, or it's something that doesn't exist, right? Like you're looking beyond the end of a tree or the end of a linked list, and there's nothing there, so we use null. But it's to me a little bit peculiar the way that Java works with this. Because certainly if I try to do this, right, if I try to do this, it's definitely going to throw an exception. Right, because x is a null object. So yeah, the part that seems inconsistent to me is that these two are not doing the same thing. Something different is happening here.
So maybe it just detects null as like it how do I say this? Like a keyword that's that can be converted to a string, perhaps.
Mm-hmm.
Because and then it does get converted to a string because it says string as equals x, which is null, plus an empty string.
Right.
So it has to. So it's just like.
So I would interpret its behavior as something like this. If x is not null, it's going to call x.toString and concatenate that. Otherwise, it's going to use the letters null. And maybe that's not really a horrible thing to do. I don't know. But like I say, that feels a little slightly goofy to me.
Yeah, so I ended up utilizing that bug or feature. I don't know what you call it. But
Mm-hmm. Right.
You need an if statement.
Yeah.
Handle it.
Cool.
I just did if is empty.
Yeah, yeah. Is empty will also tell you if the length is 0.
I'm still kind of bummed out that that method you want me to use for finding empty strings is not a proper way of doing it. I mean, I could have done it all in the process file, but I did like look. I only picked the link. The thing is that it worked for me at the end, but the problem is that even though it worked for me, when somebody else makes a random file, you know, like I think that's the hardest part about making a class is that it has to be flexible with any sort of main program being thrown at you.
Mm-hmm.
You know, which is not easy.
Right, right. So ideally, the specification is written with no ambiguity, right? And it's clear exactly what to do. But you know, the more precise the specification for a class or a method or something, the longer it's going to be, the more words it's going to have, and then you end up with, you know, the 80-page Facebook end user license agreement that nobody can read or make sense out of because it's got so much detail in it. So, you know, this isn't something that you lose points for. It's just something I'm pointing out in the user feedback section on Canvas. to just sort of like think about and keep an eye out for in future assignments. Like I say, especially at university, especially when you're doing teamwork, and you know somebody's like, okay, you're going to write the add reference method, right? And somebody else is planning to use that to store an empty string somewhere, and their code isn't working, and they don't know why, and that kind of stuff. So it's just something I'm putting out there for future reference.
Look at that. I thought that's like something that is point for some reason. I was gonna ask you that, but I feel like it would be kind of a weird question.
No, definitely not a weird question. But yeah, I'm not taking off for that kind of thing for this. All right, other questions? All right, well, it's early, but let's do a 5-minute break because I want to talk about PA3 next, and that's going to be a long topic. So let's do a short break first, and then we'll come back and start talking about PA3. So let's come back at 10:58.
I am.
Alright, we're back. Let's do PA3. Alright, so let me pull up the assignment. Let me move this over. All right. So PA3, this is the promised game of 20 questions. I am muted, thank you. All right. So so PA3, this is as I mentioned, the game of 20 questions. So 20 questions is this game. You have two people, somebody thinks of something and the other person tries to guess what they're thinking of, and they do it by asking yes/no questions. And if you ask good questions and you reason logically, you can usually guess what the person is thinking of by asking, 20 questions or fewer. But you got to be really good at asking questions. So your goal here is to write a program in Java that will play 20 questions and will guess what you're thinking of. So, first thing to note, there's a lot that we're going to describe on PA3 that's not written in this assignment. This is a 3-page prompt. That's not enough to go through all the details. We're going to spend a lot of today, a lot of Wednesday, working through the algorithms involved in doing this assignment. You will not find those details in here. So the 7 people who are in class right now, you are extremely lucky and very wise, because you can ask questions about this and ask for clarification and so on and so forth. The people who are watching this on the recording are in pretty good shape because all the details will be here, but if you have questions, right, you can't ask the recording. People who are not watching the recordings and not coming to lecture and are only looking at the prompt, well, they don't get to hear what I'm about to say, which is you're going to have a really hard time doing PA3 because there's not enough information in here to know all of the algorithms and all the details. And if you try to do this some other way, it's probably not going to work with the databases I'm going to test with. So this is good that we're going through this now. So submission details first, right? Your file is going to be called pa3.java. That's your main program with your public static void main. You're going to create some other classes for implementing binary trees and for implementing nodes of binary trees. So you're going to have a few .java files. All of those have to go into your tar file, pa3.tar. Upload those to Canvas by the deadline. If you put everything in one directory and it's all sitting in your top level directory, so that when I untar I see pa3.java, maybe tree.java, node.java, wigglybits.java, whatever, right? Then I should be able to compile your main program by just saying javac pa3.java, and that should give me your runnable class file. If you're doing anything different from that, if you're putting things into different subdirectories, if you're doing packages, if you know what packages are and so on, you got to give me a make file. Okay? Because I plan to compile by just saying javac pa3.java. Or if you give me a make file, I'll say make. And so one of those two should get me your executable class file. All right. So high-level details. Not all of this is explained in the document. Let me show you what the program looks like. and then we'll be able to talk about some of the implementation details in terms of the user experience. So. All right, so let's play a game. Let's think of an object, and I'll try to guess what you're thinking of. Is it an animal? So somebody think of something. Who wants to volunteer to try to stump the computer?
I will.
All right. So is it an animal?
Give me a sec. Could it be anything?
Yeah, yeah.
Really? Okay. It's not an animal.
Okay. All right. You were thinking of a rock, weren't you?
No.
No. Okay. All right. So what were you thinking of?
Optimus Prime.
Optimus. Isn't that an animal? Okay, so what would be a question for which yes means Optimus Prime and no means a rock?
Is it a transformer?
Can I type? All right, so now we can play the game again. And let's suppose that you're thinking of Optimus Prime again, right? So is it an animal? No. Is it a transformer? Yes. Okay, I think I've got it. Is it Optimus Prime? So this will play the game with you, and it will get, you know, in some sense smarter the more we play. All right, so yeah, go ahead. Think of an object. Let me know when you've got it in mind.
I got it. Also this machine learning aspect.
Yeah, yeah. All right, are you thinking of an animal?
No.
No. Is it a transformer?
No.
Okay. You're thinking of a rock, aren't you?
No.
No. All right, what were you thinking of?
M1 Abrams.
M1 Abrams?
Yes.
I don't know how we spell that, but that's okay. All right, so what's a question for which yes means M1 Abrams and no means a rock?
Is it a main battle tank?
A main what?
No. Is it a vehicle?
Okay, is it a vehicle?
No.
You find it in War of Thunder.
All right, cool.
Judah, please, no.
No, that doesn't actually work because you can find rocks in War of Thunder.
Okay, so suppose I'm thinking of a car, right? So I'll say, is it an animal? No. Is it a transformer? No. Is it a vehicle? Yes. Is it this? No. What were you thinking of? I was thinking of a car. What's a question for which yes means a car and no means M1 Abrams? Do most people own one? And so it's building a database of knowledge in some sense.
So basically, it's building your own binary search tree.
It's building a binary tree.
That's pretty cool, actually. But now I'm kind of curious about something like this might be a little bit tricky.
Yeah.
But maybe it's not as tricky, but it's... Yeah, you have to create like some kind of like class with like data and name and so forth.
So let's see what this is doing. We're making a tree. The roots of the nodes of the tree are questions. The first question it always asks is it an animal? So that's the root of our tree. And if you say yes, it says, does it meow? So we're going to make this decision tree, and yes is going to be the left child, no is going to be the right child. So if I say yes, it's an animal, it's going to ask, does it meow? And if I say yes, then it's going to say, does it like water? And if I say yes, it's going to say, is it a seal? And I'll say yes. Alright, so here's part of our decision tree. Is it an animal? Yes. Does it meow? Yes. Does it like water? Yes, it's a seal. If I get all the way down there and it does not like water, so is it an animal? Yes. Does it meow? Yes. Does it like water? No. Then it's a cat. I think seals bark rather than meow.
I'll just say that, like, do seals meow?
Yeah, I think they bark. I think this was a leftover database from a previous class. Alright, so if it's an animal and it does not meow, does it say moo? Yes, it's going to say it's a cow. So does it moo? And if it's yes, it's a cow. And if it's no, so is it an animal? Does it meow? No. Does it moo? No. It's going to be a dog. And then there's another set of options over here on the no side. And so as we play the game, this tree grows in size.
How big is your tree?
Well, the tree you're going to start with is pretty small. It's got 3 nodes. Is it an animal? If the answer is yes, it's a cat. If the answer is no, it's a laptop. So that's not a very good tree. But there's also a test database file available called 20qbig.txt, and this is really big. This is about 40,000 lines, so about 20,000 nodes.
How is this file set up? So, does its name have something to do with?
So we're gonna that's part of the details we're gonna go through shortly. So let's nail down the tree structure first, and then we'll talk about how to make a file for it. So if it's not an animal, I don't know. There's a simplified decision tree. So if it's not an animal, is it a vehicle? If it is, it's a car. If it's not, it's a rock. All right. So so there's 2 aspects to this. The first and simpler aspect is playing the game. And playing the game is basically, you know, print out the root node, get a yes or no from the user. If they say yes, move to the left. If they say no, move to the right. Print out the root node, get a yes or no from the user, move to the left or the right. When you get to a node that's a leaf, that's an answer. Print out the answer and say, hey, you're thinking of a cow. Or, hey, you're thinking of a dog. Right? So playing the game's pretty straightforward. You're just traversing the tree, and at each point you go left or right based on the user's answer to the question you just asked. When you get to a leaf, that's an answer. You announce, okay, I know what you're thinking of. It's whatever that leaf node is. So that's the first piece. That's gameplay. The second piece is if the final answer is wrong, you want to modify the tree. So let's say you say, does it moo? And you say no. And your program says, okay, you're thinking of a dog. And the answer is, you know, no, it's not a dog. It was a fish. All right, so we change this from an answer node to a new question node. And you say, give me a question where yes means fish, no means dog. So the question here might be, you know, does it breathe underwater? And yes means it's a fish, and no means it's a dog. And now if somebody's thinking of a fish, you'll go down the same set of questions. When you get here, instead of saying it's a dog, you'll ask this one more question, which will differentiate between the fish and the dog.
What kind of traversal is this? Is this node left, right? Or what's the, I forget, from 2.2.
So we're not really doing a traversal. We're not going to visit most of the tree when we're playing the game. We're going to start at the root, and we're going to follow a very direct path to some leaf node, which is presumably what the person's thinking of. But the decision of at each point, do we go left or right, is based on the user's response when we ask them a question. So it's not a traversal in the sense of visiting every node. It's a travel from the root to a leaf down some particular branch. But there's a third piece to this, which is putting this tree into a file and reading it out of a file, and that's going to involve traversal. And it's a little weird. It's going to be a I believe it's going to be a post-order traversal. No, it's going to be a pre-order traversal. So let me see. Yeah, it's going to be a pre-order traversal. All right, so you got the basic idea of how we play this game.
Okay.
Yeah.
So we did pre-order commercial. It's talking about like when you're constructing a binary search tree that I don't know how you did it with Java until you mentioned it or explained it, but does it just kind of construct a tree for you with in a certain traversal, or do you actually have to create like a loop of some sort?
You're going to need to do this in a loop. So the tree that we're going to use in here, you're going to create this yourself. It's not a pre-existing class. And we'll go through and see how to do that. All right, so continuing here. All right, so you'll need to implement a binary tree where each node contains two pieces of data, a string of text and some sort of flag telling you whether this is a question or an answer. And really, an answer node is simply a node that's a leaf. So I mean, you could simply look to see if your children are both null, and if they are, you know you're an answer node. Or you can put a flag in each node saying question or answer. It's up to you, but ultimately you need both pieces of information. You need to know what the string in a node is, so it's basically a tree of nodes, and you need to know if it's got any children. To play the game, begin at the root, which is guaranteed to be a question, and ask the question, and get either a yes or no from the user, and based on that, move to either the left or right subtree, and go back and ask that question. And keep going until you reach a node that has no children. That's an answer node. At that point, tell the user the answer. If the answer was correct, no action is necessary. If the answer is wrong, ask for a question to discriminate the correct answer from the incorrect one you guessed. And then make a new node with that question, and the yes and no children being the correct answer and the incorrect answer. All right. The initial tree comes from a file called 20q.txt. By default, you can specify a command line argument instead. So here's our original. Is it an answer? Answer is a cat. Answer is a laptop. Is that our original one? Yep. So if this is our original 20 questions file, and we run this, I'm thinking of an object. What are you thinking of? Is it an animal? If I say yes, it's going to say you're thinking of a cat. If it says is it an animal and I say no, it's going to say you're thinking of a laptop. right? So it's always going to start with this very simple 3-node decision tree. And that avoids edge cases of starting with a tree that's null and all of this silliness. Alright, so the initial decision tree is read from 20q.txt. If you modify it, if you guess wrong and you have to make a change to the file, rewrite the new tree back into that same file. And then the other tweak is when I run this, I can specify a different file that it should be using. So if I run this on 20q big, it will read from this other database file, which is the 40,000 line file.
So when you implement this, do we just assume that the text file is called 20q.text?
Unless the person specifies a command line argument, in which case use that. So pick up args from the main programs. Argument list, check its length. If it's equal to 1, then use args bracket 0 as the file name.
Okay.
Alright, so there's the initial database. 6 lines, so it's a total of 3 nodes, a question node and 2 answer nodes. And this file is stored with the root node, followed by the left child, followed by the right child. So this is why it's node left right, or pre-order traversal. Alright, and the usual recommendations: build this up in pieces. Start by making a binary tree class. Now this is not a binary search tree. We don't compare left and right child to the root to go left or right, right? It's just a binary tree. And instead of calling the children left and right, we're going to call them yes and no. So it'll be, you know, node.left, node.right. Those will be node.yes, node.no. Right? So don't do left, right anywhere in here, because it's just going to be another layer of confusion. Think of this as the yes child and this as the no child.
Okay. Is there a class that actually that kind of it's like a tree class in some sort?
Not that you're going to use in here. You're going to build this up yourself.
Okay.
But the tree class that you need is pretty straightforward. So there's a tree called yes. There's a tree called no. There's a string, I can call it data. That's going to be a question or an answer. And maybe a Boolean, which says, is this a question? And so at each point in our tree, you have children, which are yes and no's. Those could be null if this is an answer node, right? Then is question will be false and the children will be null. Otherwise, the children will be other subtrees. And to traverse this, right, we simply begin with the root, which is a tree, and ask the question. And if they say yes, then we change our temp pointer to, you know, temp.yes. And if they say no, we set it to temp.no, and then we ask the next question, and so on and so forth.
So the tree class and the node class are just only containing variables, kind of like a struct.
Yeah, it's kind of like a struct.
Yeah, well, not exactly like a struct, but like it behaves like it.
Yeah, yeah. And we'll do some sample code for this, and what we're going to see is similar to the linked list. We're going to end up making a node class, and we're going to want these things to actually be nodes. And then we're going to have a root to our tree, which is also a node. So we'll put out some sample code. Probably Wednesday we'll get to that. to spin out a tree-like class. All right, so continuing with details. Right, suggestion. Start by maybe just hardwiring the simple decision tree. Reading in the tree from a file, writing the tree back to a file, those are among the harder parts of this. Playing the game is among the easiest part. And so here's a few pieces to this. Play the game from a tree. So once you have a tree in memory, playing the game, pretty straightforward, right? That's probably a good first thing to work on. So construct a tree with a bunch of assignment statements first, and then play the game. So that's a good first step. And then a second step would be read the tree from memory, or read the tree from a file. And that takes a little bit of doing, but we'll talk about how to do that. That's a nice recursive algorithm. But it's definitely a lot harder than just playing the game. So get the gameplay working first, and then work on the part maybe that reads the tree from a file. And then go back and, play the game from a file and so on, make sure that works. And then update the tree in memory at the end of the game. So this business of, if your final guess is wrong, get the new question from the user, find out what they were thinking of, adjust your tree accordingly. That's a good third step of this. And you're going to use that to adjust the tree in memory, right? Forget about the file. You're just going to modify this tree. You're going to make a new node here and so on. And then go back and play the game again, and it should be able to differentiate these two things. And then your fourth part, which is actually relatively easy, is writing the tree to a file. And that's just a node left-right traversal. So that's easy to do, but it doesn't really make sense until you got these things done. So the suggestions in the assignment are basically following something like this order. So you can use scanner, PrintWriter, strings, things like that, but do your own tree class, do your own file parsing, and so on and so forth. And again, stay away from the IDEs. Do this on the command line. PA4 will use Eclipse. We're going to go through Eclipse probably Wednesday. And I posted a video last night on how to download Eclipse and get it installed for the right version you'll need for PAs 4 and 5. But for now, stick to the command line. Alright, and you run the program by either saying Java PA3 or Java PA3 followed by a database file name. So we already said that. And then there's a pair of sample files on the server under /temp. 20q.txt is this little 3 node tree. 20qbig.txt is the big whopper one, which was donated to me by a former student who was at UW, and it's, I believe, a crowdsourced database, and it's got a lot of good stuff in there. And that's only a database of animals, but it's got a lot of different animals in there. All right, and if you want to run a sample program, you can say java-cp/temp PA3, and that'll run my version of PA3, or you can put in a file name. All right, grading is pretty simplified. So if I can compile your code, that's 20 points. If I run your program and it at least asks questions and makes a guess, that's 10 points. Even if it's not guessing correctly, it's not updating, and so on. If it asks questions and makes a guess, 10 points there. If it's actually processing the database file correctly, that's 30 points. So it's got to be able to, open 20q.txt or the file name I specify, pull that in, turn it into a tree and then play the game on that tree, that's worth 30 points. If you handle args bracket 0, so I can specify a database file, that's another 10 points. And if it successfully updates the tree and the file when the guess is wrong, that's another 15 points. And then 15 points all or nothing for style. So 15 points means your name, the date, and the description of the project at the beginning of pa3.java. Consistent indenting, placement of braces, and so on. Comments on all of your code. Introductory block of comments in the front of each method, not in the beginning of the file, but in the front of each method. Block of comments describing the method, and every class has a block of comments including your name and date. Get all of those, you get your final 15 points. Any of those are missing, you lose all 15, so make sure you got all of these. I'm going to be a real stickler at this point. Alright, so pretty straightforward grading. You're going to know what grade you have before you know, submit this, because it's going to work or it's not going to work. Right, so it'll be pretty clear.
When you say all code commented, are you talking about like kind of every single line of code? That seems like a lot.
Every single line that's not completely obvious why you're doing it.
Okay.
So if you're saying temp equals temp.yes, tell me why you're doing that. What's the purpose of that statement? I know you're setting temp equal to the yes field of the current value of temp, but why are you doing that? Move to the yes branch of the decision tree. Right? Move to the next question on the yes side. Something like that. It's hard to go wrong with putting in too much explanation. It's very easy, especially if you're spending a lot of time, really intense sessions of writing code. The code's completely obvious to you. It can be hard to think, you know, hey, if I wasn't me, if this was somebody else who was looking at this for the first time, this statement would have no meaning to them, right? So you gotta remember to think of it from the perspective of somebody who's not you, somebody who's looking at the code without the benefit of all of your experience with it. All right, so let's talk about reading. Oh, I can't type. Let's talk about reading the tree in from a file. And let's look at this as a sample file. So question is an animal, answer cat, answer laptop. So that file corresponds to this decision tree. And to create that file from this decision tree, we traverse this tree in node left right order. So first we visit the root node. We're going to write this question into the file, and then we're going to, in this case, write this answer and then write this answer. And each node that we write into the file creates two lines in the file. The first line is either a Q colon or an A colon to indicate question or answer, and then the actual string comprising the question or answer. So 3 nodes creates a 6-line file. And it's a node left-right traversal. So let's suppose that we said is an animal, And if it's yes, so let's build this up. So here's our starting file. Let's go ahead and play this. So is it an animal? Yes. Is it a cat? No. What were you thinking of? I was thinking of a dog. Question for which yes means a dog. Does it bark? Alright. So now what I've done is I've modified my tree to say is it an animal, and instead of saying it's a cat, I say does it bark? And if it's yes, then it's a dog. And if it's a no, it's a cat. And if it's not an animal, it's still a laptop. Alright, so let's see what 20q.txt looks like. So node left right traversal means first we're going to write the root node. So we'll say question, is it an animal? And then we're going to output the left subtree using node left right. So node says write the root node. Now we're going to write out the left subtree using node left right. Well, this means first write out the root node, which is a question. Does it bark? And then the left subtree, which is an answer, which is a dog. And the right subtree, which is an answer, which is a cat. And that finishes the traversal of the left subtree, and then we traverse the right subtree, which is another answer node, which is a laptop. So we got question animal, question bark, answer dog, answer cat, answer laptop. And that's what our file is. Question animal, question bark, answer dog, answer cat, answer laptop. So our question is, how do we read this file and create this tree? And the goal is to basically reverse this node left right output process. So you're going to make a method. I'm going to call it ingest. So we can think of ingest as a method that reads from a scanner. Maybe we can pass our scanner object to this. And it will read a decision tree from this input stream and return that tree. All right, so here's how we do this. Read I've got this broken out into pairs of lines, either a Q or an A followed by the question or the answer, a Q or an A followed by a question or an answer. That's just to kind of simplify your parsing of the file. Otherwise, you'd have to, break off the first character and decide what it is, and so on and so forth. And this is also the format of this big file that I have. But we're always going to read in a pair of lines, and we're going to see that that pair of lines is either a question such as this or an answer such as this. So this is going to be pseudocode. So I'm going to say read a question or answer, by which I mean read in 2 lines. The first will be Q or A, the second will be some string. And we're going to make that into a node. So we're going to read the first pair of lines of the file, such as, is it an animal? And we're going to make that into a node. So we'll have a node here saying, is it an animal? All right. If the line that we read was a question, then we're going to set node.yes equal to the result of calling ingest. And then we're going to set node.no equal to the result of calling ingest. And then we're going to return. So this is our ingest method. We're going to read 1 line from the file, well, 2 lines, a Q and A, or Q or an A and a string. We're going to read in 1 question or answer. We're going to make that into a node. And then if it was a question, we're going to call ingest recursively twice. The first time we'll take the return value, set our node's yes child to that. The second time we'll take the return value, set our node's no child to that. And then we'll return this node. So if this is a question, we'll call ingest again, take the return value, put it there, call ingest a second time, put the return value there, and return this. But if an answer then we're just going to set node yes and node no equal to null, and we're going to return node. So if we read a line, if we're trying to ingest from a file and the first line that we read is an answer, we'll put that answer in our node, we'll make the children null, and we'll just return this simple tree with a single node in it and no children. And if you do exactly this, it will magically read in your file for you and build a tree in memory. All right, does that make sense?
Is this ingest file, sorry, is this ingest file inside your main program, or do you put it in a different class, or would you put it in a different class?
So you can structure this any way that you like. You can do this all in a single class, and have your main method, you know, public static void main, and have an ingest method in there, or you could put it in a tree class that you make. There's different ways you can structure this. And go ahead.
Would it be ideal if you put it inside a tree class to be organized?
Mm-hmm.
Or call it, I was gonna say constructor, but I feel like if I put it as a constructor, it'll be kind of a, I don't know, that might not be a bad idea, but I feel like that's not what he wants to do.
Probably wouldn't do it as a constructor, just because constructors generally are called to create an object, but it's a little unusual to have a constructor do too much more than that. You can do it. I mean, Java won't care, but spend some time thinking about it, maybe talking about it, kick around some ideas. Find a way to structure this that seems reasonable to you. And I'm not putting requirements on particular methods you need to implement or even particular classes other than, PA3 as your main class. But this one I'm going to leave you a lot of leeway for deciding how you want to implement it. So one idea would be to make a tree class and have an option of passing the trees constructor a file name and building a tree from that file name. I'm just looking right now. I think that's the approach that I took. Alright, so this will be the ingest method. This will read from a file on disk and create a tree in memory. The other direction, writing the tree out, that's just a pre-order traversal. So write a traverse method that basically prints the root node and then traverses the left subtree, or the yes child, and then traverses the no child. And by traversing the root printing the root node, we're talking about printing it into a file. So use PrintWriter. Did we talk about PrintWriter last week?
I don't remember that actually. I was going to ask you about how we actually add things to the file.
Alright, we'll do PrintWriters next. I did those in the Thursday class. We didn't get to them here. So we'll talk about PrintWriters. PrintWriter is a way that we can print into a file instead of printing to standard out. And so we'll do a pre-order traversal of the tree and write the results of that traversal into a file that creates the database file corresponding to our tree. And then the only other piece that's missing is this business of adjusting the tree when you're done playing. And the way we do that is when you get down, as you're playing the game, so you start with the root, you move to the no, ask if it's a vehicle, they say no, you move over here, you say it's a rock, and they say no, it's not a rock, it's a desk. All right, so you get the new question, do you sit at it? And you know that there's a correct answer, desk, and there's the answer you guessed incorrectly, which was rock. So you have to know which node you came from, right? You have to remember the previous question that you asked and the answer that was given, because this is the thing you want to modify. And right now this is a leaf node. You want to change this to be a new node which contains this question and has a yes child containing desk and a no child containing rock. And then you want to set vehicles no child to be this new node.
Well, are you replacing it with the question, or are you essentially kind of taking the vehicle, and I was going to say pointers, but that doesn't exist in Java, so I don't know, I'm trying to think of some way to reference. You said I was thinking replace, but that's all I can think.
You could replace. So if this thing's no child is this node right here, you could change the question here from the string here from rock to do you sit at it, and change the yes and no children from being null to being new nodes containing a desk or a rock. And your goal is to effectively change from this into this, so that as you play the game, next time you come down here, ask if it's a vehicle, and they say no, you'll go ahead and you'll ask one more question, and then differentiate between those two possibilities.
see.
So, so can I store rock as a string and then have that be the right node of the new question? That's kind of it's like a temp variable basically.
Yeah, just be really careful how you do this. Right, so this is a node. It contains, 3 or 4 pieces of information. It contains a string and a yes child and a no child and maybe a flag saying it's an answer or a question, right? This is another node that's going to look like that, but don't try to cut code and set this equal to that, because you'll end up, maybe creating some kind of horrifying loop like that or something. Just if you have this string and a temporary variable, make a new node and set the data field equal to whatever that string was that you saved here, and set the yes and no children to null.
Okay.
Yeah.
That's kind of referring to it, but then you referred it as a node. I was thinking the string in that node rather than the string itself. That would cause an error.
Oh, okay. So to structure this, you probably want tree class and a node class. Kind of like we did for a linked list. So your node can contain, some text. A child node called yes, a child node called no, and maybe a Boolean to tell you if it's a question. But you could put a method in here called isQuestion that basically tells you if both children are null. And if yes is null and null is no, then it's not a question, it's an answer. Or you could use a Boolean, so your choice. But you definitely need to have the text of the question or answer and a pair of children, which are either the nodes to go to for a yes or no for a question, or they're null if this node is an answer. And then the tree class, well, every tree needs a root. So make a node called root and initialize it to null. That's an empty tree. And the main purpose of the tree class is just to hold this root. Right? And the root is a node, so it's the node that has the children and has the data field and so on and so forth. But then you can put things inside this class for traversing it, or for building it from a file. So how do you do a node left-right traversal on the tree? Well, if the root's null, you don't have to do anything. Otherwise, print out the root node's text, and then do a node left-right on root.yes, and then do a node left-right on root.no. And so on. We don't need to search the tree. We don't need to delete from the tree. We definitely don't need to balance the tree. So most of the things we've done with trees in 222 don't apply here. Really, the only things you're going to do with a tree are you're going to start at the root and travel down. In other words, you're going to play the game. And so you might have, a play game method, which says, start at the root, print the string, get a yes or no, change your temp to either, you know, node.yes or node temp.yes or temp.no, and keep going until you get to an answer, and so on. So you need to start at the root and move down the tree to play the game. That's one thing. You need to be able to write the tree into a file. That's the node left right traversal. And you need to be able to build the tree from a file. And so that's another method you'll make, and that's that ingest or read tree business. All right. So what would node left right look like for traversing? So we'll definitely do this in code on Wednesday. This is kind of a first pass. Traversing a tree like this is going to work best if we put a traverse method in the node class. Because if this is a method in the tree class, I can't really say root.yes.nodeLeftRight, because root.yes is a node. I can't say root.nodeLeftRight because root is a node and nodeLeftRight is in the tree class. So this is like a wrapper around our traverse code. So we could do something like this. If root equals null, just return. Otherwise, root.nodeLeftRight. And then in our node class, we can have a void nodeLeftRight, which says print the text, and then yes.nodeLeftRight and no.nodeLeftRight. But you got to throw some logic in here. Make sure yes is not null. If this is an answer, then we don't need to go into its children. It has no children, right? So our traversal of a node says print out the text, and if it's a question, then traverse the yes and no children with this same pre-order. And then node left right in our tree class is just a wrapper around node left right on the root. But we're doing this because in our main code, we're going to do something like, you know, tree, the tree. And then when we want to traverse it, we might say, you know, the tree dot node left right.
Is the node left right method recursive in the way that it just goes through? It kind of goes left and right.
Yeah, so it prints the root node and then it traverses the left and right subtrees, the yes and no trees, using the same NLR method.
So essentially just kind of, I thought it was going to be like, I don't know, I was thinking something a little bit different of like, I keep thinking of C in my mind, where we use pointers, but it's very different where in Java it seems like when you're creating a new node, that's the child. You just kind of like you basically just create a node and have that be the, I don't know. It's still confusing to me for some reason.
That's okay. It is very similar to C. The syntax is different. We're not using explicit pointers, but it's very much the same process. And this is recursive in the same way that our traversals were recursive in Winter. Where this structure has, you know, in some sense pointers to things similar to itself. This is a node. Yes is a node. No is a node. right? They were pointers to nodes in C, but same idea, that refers to another node and another node. And to traverse this node, or to traverse the tree whose root is this node, first you print the text itself, and then you traverse the yes and no subtrees. How do you do that? By using the same method that's right here on the yes and no subtrees. So we would say NLR parentheses, you know, root arrow left, or root arrow yes. But with objects, we just say, you know, the name of that root arrow yes, which is just yes, dot, and then the method we want to run. But it's really doing the same thing as saying, you know, print the data, traverse root arrow yes, traverse root arrow no. All right, so we'll write some code for that today if we have time, but definitely Wednesday. But let me mention PrintWriters as a way to do output from Java into a file. And PrintWriters are in some sense easier than scanners. They're a little easier to construct. So here's a PrintWriter. So you have to import java.io.printwriter, and you can construct it with a name of a file you want to create. This can be a whole path, or it can just be a file in your current directory, and that can go straight in as the argument. So you don't have to use a new file. You could, but you can also just say new PrintWriter parentheses and the name of a file. And once you have a PrintWriter object, what can you do? You can do things like print line. You can print line a character or a string or an int or things like that. So the method is exactly like system.out.println, but instead of writing to standard out, it will write to whatever file you specified when you constructed the PrintWriter. So this right here. And this can throw an exception if you don't have permission to access the file, or it's in a directory that doesn't exist, and so on. So you have to catch exceptions. But other than that, it's completely straightforward. So so let's try this.
You actually need to do the exception if let's say, can you check the file that exists before you even use PrintWriter?
You could, but you'd still have to catch the exception, because the compiler doesn't understand that you're going to check that and ensure that the file exists. And the file could disappear between the time that you check to see if it exists and the time you open the PrintWriter. So you're going to be forced to catch the exception.
Okay.
So we'll import java.io.printwriter. Let's open a file. So I'll make my PrintWriter called PW. I'll try PW equals new PrintWriter. We'll make a file called hello. I'll be lazy and just catch the universal exception. And I'll say error opening file. I'm not going to worry about typos because it's noon, so I'll return in that case. So now we can write to our PrintWriter, PW print line. This is a test. I'll just keep going with the typos. That one will have to go away. And then I will just exit at that point. Alright, so here's our directory. Let's compile this. We've got our class file. I'll go ahead and run that. And now I've got a new file called hello, and if I cat it, it's got nothing in it. So why is there nothing in it? So PrintWriters...
Is it only work with text files?
Nope, it should work with any type of file. So there's a method in PrintWriter called close. And unlike C, you have to be really good about closing your streams. So closing releases the resources associated with opening that file, but it also takes everything that's been printed to that file but hasn't actually been sent to it yet, and it flushes that out. And real briefly, this is this idea of buffered output streams. So when you say print line, you've got some file sitting on a hard drive here, and you're trying to print into that file. Your print line statement does not go directly into that file. It goes into this internal buffer, which saves up everything that you're printing until you've got like a big chunk of stuff that you want to write. And once you've got enough stuff buffered up, then it's worth the time to take that chunk of bytes and send them out to your actual file. But if you tried to actually write to your file on your hard drive every time you printed a character, it would be incredibly slow. Because this is a really expensive operation. This is a very slow behavior, right? Your disk spins 7,200 times a minute. And you can write a character in, a few nanoseconds maybe. So this would be a bottleneck. So your output is typically buffered. When you say .close, anything that's sitting in this buffer that hasn't gotten written to the file yet gets dumped out. And if you want to force that behavior without closing your file, you can also say flush. We used flush statements in 224 for same situation. So you could also say .flush, and that'll take whatever's sitting in the buffer and dump it out, but leave the file open. If you don't do that, it's possible you write a bunch of things with print line, your program exits, nothing got written into the file.
I'm kind of curious, is putting things inside the buffer same idea as putting it into memory, into some kind of what you call buffer?
Yeah.
But and if you were to close the program without closing the file, it just kind of what happens to it if it was still in memory? Would it just disappear?
It just goes away into the ether.
Okay.
Yeah. It's a little bit like ejecting, like yanking out your USB drive without ejecting it. Ejecting is flushing the internal memory buffers to actually write them out. So if your program just terminates, then it's kind of like you didn't push that stuff into the device.
Can you go back to what you were showing a minute ago?
Mm-hmm. This. And most output that we do as users is buffered. Print lines are buffered. Puts or fprintf in C are buffered. If you're doing very low level stuff, if you're doing binary output, you may use unbuffered streams. But this is going to come in PA5 when we're doing networking. Same thing, our networked operations are going to be buffered. If you want to send a message to another machine, it's not enough to just print it to that machine. You also have to make sure you flush it so that the machine sees it right away, especially if we're handshaking. If I want to send a message and get a response back, I have to make sure that message not just got loaded into an output buffer, but actually got sent where it's going. So we'll find flush saving the day for us a lot. And then just for completeness, you know, if my file's not accessible and I try to open a PrintWriter on it, I'll throw an exception. In this case, I caught the exception and printed out a typo message saying error opening file, right? And that's an error because I don't have write access to the file hello. In fact, I have no access to it because I changed permission bits to 0. So that's why you have to catch this.
I got a question about permission bits.
Yeah.
So for permission bits, does it? So I'm assuming that you're the admin of their file, right?
Mm-hmm.
You're allowed to. So you have permission to change the bits.
Mm-hmm.
So, and this is only like, is this file kind of attached to you as the admin, but everybody else like has to follow the rules of whatever permission bits you give?
Well, this file I have control over because it's owned by me. I'm logged in as Nick, and Nick is the owner of this file. So even though it's listed as no permission, I can actually change these bits back. And in fact, if I try to remove it, it'll tell me, hey, it's write protected. You really want to remove it? And I can say yes, and it'll go ahead and do that. But in a more general context, if this was owned by somebody else and I didn't have permission, you could turn on your admin privileges, right? Basically become super user, and then basically the permission bits are ignored. And that's how you have access to things like, you know, the files corresponding to physical devices and things like that. What's really bad, though, is if you accidentally change every file in your system to have a permission of 0, that's a hard one to undo, even as an admin. I did that once by mistake, pretty recently. And, you know, you can't execute any of your commands like, you know, ls or change mode or things like that because the permission bits don't allow execution. So I don't remember how I got out of that. It took me about 20 minutes, though.
I was thinking, like, if I'm thinking like a security class, they might say, like, using chmod is a very bad way of protecting their files, or I don't know.
It's kind of the only way up front. I mean, encryption is better, but short of that, it's the main protection mechanism is these permission bits. And you can have permission bits on directories as well. And if you set your directory bits so that, you know, everybody except you has no access, then even if a file's accessible, right, people can't do an ls on your directory. And they can't change into that directory, and so on and so forth.
Okay.
All right, so we're out of time here. So Wednesday, I want to put together a sample tree class. Not the exact tree class we'll use for this, but we'll put together a sample tree class just to kind of see a way to structure things in terms of trees and nodes, and where we put the methods for traversing and so on and so forth. So we'll probably do a simple binary search tree on Wednesday, and then you can expand on that into a decision tree, and that should give you all the pieces for PA3. All right, so we'll play around with that, and I will probably also play around with Eclipse and go through which version to download for Eclipse and for Java to get ready for PA4. And we'll talk about the next ODP also. All right, that's all I got. Have a great afternoon. I will see everybody in office hours tomorrow or in class on Wednesday. All right, thanks.
Thank you.